All right, looks like it's working. So we'll see if this works. Hopefully it will. All right, so a couple different things. You can graph them on your calculator just to check. But like I mentioned before, the quiz and the test on all this is non-calculator. Okay, so your calculator is only going to help you as you're graphing these. So I'll kind of go through, once we get to kind of a fun one, I'll walk you through all this stuff. In order to graph it on the calculator, though, you do have to have some specific things about the mode and these symbols and the window. So I'll go through that in a little bit. A couple things that we want to talk about, and I'll highlight important phrases on here. This one in particular. Most cosine graphs have x-axis symmetry. So that's something you want to remember. Cosine always goes with x. X is equal to cosine. We know that, right? So cosine graphs usually will have symmetry about the x-axis. Similarly, most sine graphs will have y-axis symmetry. So most of these graphs, if they have a cosine, they're going to be going on the x-axis. If they have the sine, they're going to be going in the y-axis direction. Okay? Christian, you good? Do you have your notes? Oh, okay, good. If you don't, I have an extra copy if you need it. Okay. We're going to start with a couple easy ones. So the first one is a circle graph, and the equation is very simple. It's just r equals a. Okay, so a is just any number. So what does that mean in terms of a description? It's just a circle with center at the pole. Remember, we call it the pole, not the origin. And radius a. All right, so very easy. We just say, like, for example, what if I asked you to graph r equals 3? Well, it would be a circle with the center at the pole with a radius equal to 3. So here's my pole. I'd go out 1, 2, 3, and it's just this circle. And you're done. That's it. So that's a very simple one. It could also be another name for this exact same circle would be r equals negative 3. Because if you're going in the negative direction, you're still going to trace out that circle. Okay, so that same circle, very basic, very simple equation. These are kind of our, starting with the easy ones. Okay, the second one, which is also very basic, very simple, is a line. And as we go through, you kind of want to memorize these. This is why I gave you those note cards today, because the note cards have each of these shapes. And so you need to memorize the shape with the equation that goes with it. So the line equation actually starts with theta. It is the only one that's going to start with theta instead of all the others are going to start with r. R, right? We're dealing with r's and thetas. No more x's and y's here. Okay, so it's all r's and thetas. So this one starts with theta equals a. Okay, so what is this? This is a line along the angle A, wherever it is, with arrows in both directions. So it goes on forever along that line. Let me show you what I mean. Example, let's graph theta equals pi over 6. And these are going to be given to you in radians. So I go along that angle pi over 6, which is right here, 30 degrees. And it goes all the way, and it even crosses over into the other quadrant as well. Arrows in both directions. That line could also be named theta equals 7 pi over 6. Or it could be theta equals negative 5 pi over 6. Or theta equals negative 11 pi over 6, right? We've got lots of different names for that same line. Okay? Negative 11 pi over 6. Yeah? Does that work, right? Yeah. Okay, any questions so far? Circle and line. Easy peasy. Let's do the hard ones. Oh, these ones are still easy. This whole page is easy. We'll get tricky on the next page. All right, so a cosine circle and a sine circle. These are our next two. All right, so cosine circle, here's your equation. R equals A cosine theta. So A cosine theta. It'll have a coefficient in front, and then it's cosine. Similarly, the sine circle, same idea, but it's now A sine theta, okay? So for A cosine theta and A sine theta, very similar, just a little difference, and the difference is going to be that symmetry that I mentioned up at the top. We said that a cosine circle was going to be symmetric about the x-axis, right? And so the description here is that it is a circle two, I'm going to say circle, symmetric about x-axis, tangent to y-axis. And then tangent means touches it in one place, right? So it's tangent to the y-axis. Makes more sense almost on these when I show you the picture. Okay. So let's do an example. I'll give you some numbers. R equals, I'm going to go ahead and do negative 3 cosine of theta. All right, so what does the A represent and what does the negative represent? So A, let's write a little note here, is the diameter of your circle. If it's positive, it goes to the right. If it's negative, it goes to the left. So I'm going to have a diameter of 3, but it's negative, so I'm going to the left. So you start at your origin. It's going to the left 3. That's the diameter of my circle, and then I just draw a circle. It's symmetric over the x-axis, right? Symmetric about the x-axis. If I fold it in half, it'll be exactly symmetric over the x-axis. It's tangent to the y-axis, meaning it touches it once right here on the y-axis. The diameter has a length of 3. It went to the left because of the negative. Make sense? So could you all graph a sine circle now? Let's think about it. So it's the same idea, except that sine circles are going to be symmetric about the y-axis. And they'll be similarly tangent to the x-axis. Now, same thing, A is still your diameter. What do you think positive is going to mean in this one? It's going to be up, and negative is going to be down, because we're going in the y-axis direction. So again, your sine graphs, you always are going y-axis up and down. Your cosine graphs, you're going left and right. All right, so let's have you guys graph. R equals, we'll do 4 sine theta. So what would 4 sine theta look like? It's positive, so it's got to go up. Diameter of 4. So I go 1, 2, 3, 4. Tangent to the x-axis at the pole. Symmetric about the y-axis. Is that what you do? That's it. Nice, easy circle. Your circles don't have to be perfect. Mine never are. So those are our first 4. So we've got a circle, which is just, right, centered at the pole. We've got a line, and then we've got cosine circles and sine circles. The tricky part is that that is their diameter on these ones versus the other one that was the radius up there, okay? Any questions so far? Ready for the trickier ones? Let's do the fun ones. Okay, cosine cardioids and sine cardioids. All right, I'm going to pause this video just because sometimes they get too long.